Це можете розпочинати.
Так, доброго дня, шановні колеги. Сьогодні 24 січня 2024 року. На даний час 10 годин 5 хвилин. Ми захист починаємо трошки пізніше через технічні причини. Отже, дозвольте розпочати засідання. Відповідно до наказу ректора номер 635К від 15.11.2023 року у Сумському національному аграрному університеті утворено спеціалізовану вчену раду для прийняття до розгляду та проведення разового захисту дисертацію Лі Фанг на тему порівняльна оцінка різних методів визначення залишків пестицидів у рослинній продукції. На здобуття ступеня доктора філософії у галузі знань 20 аграрні науки та продовольства за спеціальністю 202 захист та карантин рослин. Склад ради. Голова ради Міщенко Юрій Григорович, доктор сільськогосподарських наук, професор кафедри агротехнології та ґрунтознавства Сумського НАУ. Рецензенти Коваленко Владислав Миколайович, тут присутній, кандидат сільськогосподарських наук, доцент, виконуючий посаду завідувача кафедри біотехнології та хімії Сумський національний аграрний університет. Лукенко Андрій Олександрович, також наявний, кандидат сільськогосподарських наук, доцент кафедри агротехнології та ґрунтознавства Сумський національний аграрний університет. Опоненти. Станкевич Сергій Володимирович, присутній на відеозв'язку, кандидат сільськогосподарських наук, доцент, завідувач кафедри зоології, ентомології і фітопатології, інтегрованого захисту і карантину рослин імені Литвинова, Державний біотехнологічний університет. Немирицька Людмила Вікторівна, також присутня онлайн, кандидат біологічних наук, доцент кафедри агрономії і лісове господарство Житомирського агротехнічного фахового коледжу. Таким чином, посади членів спеціалізованої вченої ради вказані на дату захисту дисертаційної роботи. Прошу зареєструватися, шановні рецензенти та опоненти, з завіренням ваших підписів. Отже, на підставі реєстраційної картки нас присутні 5 членів спеціалізованої вченої ради із 5 затверджених наказом ректора номер 665 від 15.11.2023 року. Таким чином, кворум для початку засідання є, і ми маємо всі підстави для того, щоб розпочати засідання. Отже, засідання спеціалізованої вченої ради оголошую відкритим. Так, порядок денний на сьогодні. Це захист дисертації на здобуття ступеня доктора філософії, аспірантки кафедри біотехнології та хімії Сумського національного аграрного університету Лі Фанг на тему порівняльна оцінка різних методів визначення залишків пестицидів у рослинній продукції. За спеціальністю 202 захист та карантин рослин. Роботу виконано у Сумському національному аграрному університеті. Науковий керівник, кандидат сільськогосподарських наук, доцент Дубовик Володимир Іванович. До спеціалізованої вченої ради надійшли такі документи. Це заява щодо проведення атестації здобувача, копія першої сторінки паспорта громадянина Китайської Народної Республіки, копія диплома магістра, витяг з наказу про зарахування до аспірантури, який засвідчений у встановленому порядку, академічна довідка про виконання відповідної освітньо-наукової програми, висновок наукового керівника, доцента Дубовика Володимира Івановича, висновок про наукову новизну, теоретичне та практичне значення результатів дисертації, дисертація в друкованому та електронному вигляді, відбитки копій трудових публікацій, зарахованих за темою дисертації, засвідчені у встановленому порядку. Всі документи відповідають встановленим вимогам. Дисертація до захисту подається вперше. Хто за запропонований порядок денний, прошу голосувати. Хто за? Проти? Немає. Утримався? Також немає. Отже, 5 з 5 за. Пропозиція приймається. Так, дозвольте зачитати біографічні дані аспіранта. Лі Фанг 1989 року народження, громадянка Китайської Народної Республіки, має вищу освіту. Закінчила в 2015 році Сіхуанський університет Китайської Народної Республіки за спеціальністю комп'ютерна архітектура. Аспірантуру закінчила в 2023 році Сумського національного аграрного університету Міністерства освіти і науки України в місті Суми. Дисертація виконана у Сумському національному аграрному університеті, також місто Суми. Тема дисертаційної роботи затверджена на засіданні вченої ради Сумського НАУ від 25 листопада 2019 року, протокол номер 5. Лі Фанг завершила виконання освітньо-наукової програми у 2003 році. 25 серпня 2023 року відбулася публічна презентація дисертаційних досліджень на кафедрі біотехнології та хімії за спеціальністю 202 захист та карантин рослин, де дисертацію було рекомендовано до розгляду та захисту у разовій спеціалізованій вченій раді. Основні положення та отримані наукові результати дисертаційної роботи висвітлено у 15 наукових працях. З них 4 наукові праці оприлюднено у фахових наукових виданнях, 5 наукових праць у наукових виданнях, включених до наукометричних баз Scopus та Web of Science, 6 наукових праць, опублікованих в інших виданнях. Наукові публікації відповідають вимогам пункту 8 та 9 порядку присудження доктора філософії та скасування рішення разової спеціалізованої вченої ради закладу вищої освіти наукової установи про присудження ступеня доктора філософії. Це постанова Кабміну України від 12 січня 2022 року за номером 44. Дисертація відповідає вимогам наказу Міністерства освіти і науки України номер 40 від 12.01.2017 року про затвердження вимог до оформлення дисертацій та порядку присудження ступеня доктору філософії та скасування рішень разової спеціалізованої вченої ради закладу вищої освіти наукової установи про присудження доктора філософії. Постанова Кабміну України від 12 січня 2022 року за номером 44. Чи є питання у членів спеціалізованої вченої ради? Немає. Із здобувачем погоджено, що захист дисертації буде проводитись англійською мовою. To present the main results of the research, the work is given to graduate students, Лі Фанг. Please, Лі Фанг.
Okay. So I will start my present. Okay.
Yes.
Good morning, my dear professors. My name is Lí Fang, and my PhD tutor is Dobrovica Vladimir Professor. Today, I stand here for my dissertation defense. Thanks for your participation. My research topic is comparative evaluation of different methods of determining pesticide residue in plant products. And now I will introduce my research achievements from following 4 aspects: research background, research methodology, list of publication, and acknowledgement. As we all know, pesticides are widely used chemical compounds in agriculture to destroy insect pests and weeds. This extensive usage has increased the crop yield as well as led to significant reduction in harvest loss and thereby enhanced food availability. Here is the equipment for high-performance liquid chromatography method, which was commonly used in the detection of pesticide residue in plant products. Electrochemical sensor is a kind of sensor which converts the detection signal into electrical signal based on the electrochemical properties of the target subjects, and then formed the electrochemical analysis system like this. Here is my research technology route. Next, I will describe my research work in detail. Work 1. The absorption and accumulation of imidacloprid precipitation in several hydroponic leaf vegetables. Imidacloprid, short for IMI, was taken as the test pesticide, and those 5 cans of vegetables were taken as research objects. Firstly, we explore the optimum chromatographic conditions and get the chromatogram of IMI standards and the standards cover, and then get the linear range of IMI, and the coloration coefficient is 99.89%, which can meet the needs of qualitative analysis. Here is the relative standards, deviation, and the peak recovery result. It can be seen that this method of pesticide presented meets the requirement of an analytical standards for pesticide residue experiments. So this experimental method is effective for the detection of IMI in leaf vegetables. Then I explore the residue concentration of IMI in different parts of different leaf vegetables. The residue concentration of IMI in the root of green grasses is the highest, and the reduce in the stem and leaf of Petroc GMC is relatively small. The residue concentration of IMI in literal leaves reached the peak at 10 days, and the decreased at 15 days, compared with 10 days, which may be related to the degradation mechanism in plants and the transpiration of leaves. Conclusion. The distribution, dynamic transfer differences of and the rules of IMI in leaf vegetables water system were primarily proved through hydroponic experiments, and leaf vegetables with high and low residues of imidacloprid were screened out, which provide a scientific basis for guiding the ratio and the safe use of common pesticides such as IMI. Work 2. Determination of sabbatism in vegetables by electrochemical sensor and valued by high-performance liquid chromatography. The fiber process as shown in Scheme 1. Here is the EIS and CV of the Bayer GCE and the new sensor, which indicating that the introduction of MWCNGSOOH significantly improved the electrochemical sensor analysis performance of CBZ, which has close association with the one-dimensional home conductive carbon structure and the carbon functionalization of MWCN-TCOAH. In order to obtain better detection performance, we explore the detection experimental conditions about scan rate, pH, and accumulation time. Under explored optional conditions, the sensor for CBZ determination presents a significantly lower limit of detection, and the Lambda range is 0.03 mmol to 20 mmol. This table shows reproducibility, stability, and interference of the sensor, which shows good performance. The above result confirms good practice feasible of the MWCNTCOH sensor for the 3 kinds of vegetable. Conclusion. The new sensor fabricated for the detection of CBZ was feasible, and the detection effect for practical sample is good. Work 3. Determination of imidacloprid in vegetables and by electrochemical sensor based on soil bee-derived pounds carbon and evaluated by high-performance liquid chromatography. The fabrication process of the sensor for the determination IMI and the auction mechanism of IMI as shown in scheme 2. This is the SEM message of the SDPC sample, which showed a three-dimensional pulse structure with interconnected large pulse and carbon walls. By comparing CV valves, the Bayer sensor, the SDPC GC sensor present much higher peak current response, which has close association with the 3D interaction porous structure of SDPC with high electroconductive and large specific surface area. In order to obtain more extensive IMI detection performance, the influencing factors such as accumulation time, dropping current amount, and pH were optimized. Under the employed optimized conditions, the sensor for IMI detection presents a low limit of detection and a linear range is 0.3 mmol to 75 mmol. Compared with the published studies, our work can show a more sensitive detection performance to IMI, mainly in a low LOD and high sensitivity. This table shows the reproducibility, stability, and anti-interference of the SDPC GCE sensor, which shows good performance. In order to investigate the practicability of the sensor, the standard addition method was used to quickly detect IMI in tomato and cucumber and literature sample. Conclusion: the soybean-derived compound carbon was used to modify the glass carbon electrode for the fabrication of SDPC GCE sensor towards IMI, which shows good practical application value in the analysis of IMI in complex matrices. Work 4. Determination of methane pathology in vegetables by electrochemical sensor based on superconductive carbon blank zirconia and evaluated by HPLC. The fabrication process as shown in scheme 3. SCB nanoparticles present good conductive property based on the point-to-point contrast of conductive carbon nanoparticles. Zirconia nanoparticles present good recognition and enrichment ability towards multiparity due to the high affinity of nanoparticles for the phosphate group on methyl coils. The same waves shows the efficiency. The experimental conditions were optimized, including mature drip counting amount, scan rate, accumulation time, pH, and buffer solution. Under explored option conditions, superconductive carbon black zirconium sensor for MP detection performance present a low limit of determination and a Lagrange range is 0.03 mmol to 10 mmol. Compared with the published studies, our work shows good MP detection performance. In order to improve the practicability of the sensor, the reproducibility, stability, and anti-interference of the sensor are further discussed by using DPV method. According to the above experimental results, both electrochemical sensor detection method based on SCB, ZrO2 and the HPLC detection method realize the actual detection of MP residue in vegetable samples. There are 3 vegetable samples. In the conclusion, as a fiber sensor exhibited a low LOD value in MP lambda concentration range under the optimal conditions. In order to improve the detection performance of method piracy by electrochemical sensor, we designed the following experiments. Work 5, determination of method piracy in the vegetables by electrochemical sensor fabricated from biomass structure and base cycle trained functional compounds carbon half-phase and evaluated by HPLC. The fabrication process as shown in scheme 4. The surface morphologies of the assays of SGCS and SGPCS samples were characterized by SEM techniques. Electrochemical behavior of MP for the sensor. The CV measurement result shows the highest peak current value. In order to obtain better MP detection performance, the experimental conditions were optimized, including scan rate, pH, and accumulation time. Under the exploratory optimal conditions, the sensor towards the electrochemical determination of MP shows linear correlation. This table shows the comparison of MP and the sensor and other reported MP sensors. The fabricated sensor shows a relatively low LOD compared to other reported MP sensors. For the reproducibility and repeatability measurement, there is no much difference between the peak current value of the MP. The low relative standards deviation suggests that the satisfactory reproducibility and the repeatability of the sensor was achieved. According to the above experimental result, both an electrochemical sensor determining method based on the SGPC and the built CDGC and the HPLC detection method realize the actual detection of MP residue in vegetable samples. Conclusion. The nanocomposites was used to modify the glass carbon electrode for the fabrication of of the sensor towards MP. The experiment has achieved a satisfactory result. Here is the list of publication. 5 articles have been published and indexed in Web of Science. 4 of them are in Q1 and 1 of them in Q2. 4 articles in the scientific journals included in the list of the scientific professional journals of Ukraine ranked category B. 6 articles have been published in international congress. And that's all. Thank you to my tutor, Vladimir Professor, for his patient guidance. Thanks for your listening.
Okay, the report is
Okay.
completed. Please ask questions. Colin, please. Your questions.
Thank you for your presentation. I have 2 questions. First question for you. Why perform highly sensitive and efficient analysis for pesticide residues on plant products? Are you here or repeat for you?
Please repeat. Sorry.
Why perform highly sensitive and efficient
Oh,
analysis
okay.
for pesticide residues on plant products?
Okay. As we all know, pesticides have played an important role in improving the crop yield and eliminating the pest and disease in modern agriculture. However, the improper use of pesticides often leads to the excessive pesticide residue, which cause serious harm to human health and the ecological environment. With the development of society, people pay more and more attention to agricultural products in order to monitor agricultural products safety and provide guidance on agricultural products activities. Highly sensitive and efficient analysis technology of pesticide is required. Thank you.
Thank you for the answer. And the second question. What are pre-treatment steps of vegetable samples for high-performance liquid chromatography method?
Okay, thank you for your question. Each vegetable sample was washed and dried, and then cut them into pieces and put them into a homogenization for homogenization. 10-gram sample were weighted into a 15 milliliter centrifuge. 2 grams NaCl and 10 milliliter temperature are added and blended and worked for 3 minutes, then concentrated for 5 minutes and 3005 rand. A quantity of 2 more was transferred from the substance to a new clean 2 ml centrifuge tuber concentrate a certain amount of PSA and GCB purification materials. The sample were again vetted for 3 minutes and then centrifuged at 10,000 rand for 5 minutes. Afterward, 2 substances was taken and filtered them through 0.02 mmol filter mental balance before sampling. Generally, vegetable samples without any pesticide were taken. A certain amount of standard mixture was added, and the determination was repeated for 3 times according to the given chromatographic conditions. Thank you.
Thank you for the answer. No more questions. Thank you.
Okay.
Okay, thank you.
Andrei Alexandrovich, your questions?
Questions. What are the difference in the absorption of pesticides between different kinds of leaf vegetables?
Okay, thank you for your question. When leaf vegetables were treated with high concentration, the residue concentration of IMI in root, stem, and leaves of plants were significantly higher than that of low concentration. Additionally, there are great differences in the absorption of IMI from stems and leaves by roots of different varieties of vegetables. The residual concentration of IMI in the root of green grass is the highest, and the residue in the stem and the leaf of partial GMC is relatively small. Thank you.
The second question. What are the traditional pesticide residue detection methods? And what are the advantages and disadvantages?
Okay, thank you for your questions. The traditional analysis technology of agricultural residue include gas chromatographic, liquid chromatography, high performance liquid high chromatography, and chromatography mass spectrometry, and so on. The disadvantage are maturity equipment, high accuracy, high sensitive, and the disadvantages are expensive equipment, professional operation, and time consuming. That's all. Thank you.
Okay. Сергій Володимирович, your questions, please.
Так, чути добре.
Так, так.
I have two questions. First question. What pesticide resist detection methods are compared in your dissertation? And what are the advantages of the new method in comparison?
Okay. I studied 4 kinds of electrochemical sensor technological based on different carbon materials to detect pesticide residue in order to compare the performance in actual sample detection. The classical method based on high performance liquid chromatography was studied, and then the experimental results were compared. Under the optimum conditions, the detection of pesticide residue result by electrochemical sensor is basically consistent with high-performance liquid chromatography, indicating that the electrochemical sensor method is relatively accurate and reliable, and can be used as an alternative method for the detection of pesticide residue in vegetables. What's more, electrochemical sensor method has disadvantages of low of pesticide residue in vegetables. What's more, electro has a simple operation and easy to care, which make it possible to detect plant production pesticide residue on site. Oh, that's all. Thank you. Thank you for your question.
Thank you. And second question is, how many kinds of pesticides were detected by electrochemical sensor method in your dissertation?
Okay, in my dissertation, I detected a total of 3 kinds of pesticide. They are carbendazim, imidacloprid, and methylpalethrin. Carbendazim is a common used fungicide. Imidacloprid is a kind of nicotinic pesticide. Methylpalethrin is a widely used organophosphorus pesticide. The three of them present different pesticide type. Okay, that's all. Thank you.
Thank you.
Okay. Людмила Вікторовна, please, your questions.
What are the advantages of biomass-derived porous carbon? What role does porous carbon materials play in enhancing the performance and pesticide residue assessing analysis?
Okay, thank you for your question. As a renewable resource, biomass carbon has advantages of low price, abundance, drainage, and environmental friendliness. Biocarbon materials not only have the disadvantages of extensive sources, low cost, and high yield, but also show the advantages of large specific surface area, high electroconductive and strong chemical stability. Using biomass raw materials to produce a variety of carbon materials not only can reduce the production cost, but also can realize the sustainable development of carbon materials. Porous carbon has a rich porous carbon conductive network structure, which can improve the transfer efficiency of the sensor electrode surface and increase the adsorption capacity of the electrode surface to agricultural residue molecules, providing a large electrochemical active area. That's all. Thank you.
How is the repeatability and reproducibility of sensor analysis technology arrived in your experiment?
Okay, thank you. Repeatability is that 5 repeatable measurement and 1 individual modified sensor were carried out. Reproducibility is that 5 identical sensors were fabricated by the same method for 5 individual measurements. The experiment result showed that the relative standards deviation for 5 independent measurements of electrochemical sensor and 5 conservative measures using the same sensor. The low RSDS confers the excellent reproducibility and repeatability of the prepared electrochemical sensor. That's all. Thank you.
Thank you.
Okay, I have our 2 questions. How to realize anti-interference between multiple pesticides residues in sensor analysis technology?
Okay, thank you for your question. The anti-interference has an important influence on the detection performance of the conducted sensor. In this part, some common origins raw and pesticide with similar structure were selected as a distributor. For example, interference errors with a concentration of 100 mmol and some other pesticides with a concentration of 10 mmol were mixed with 10 mmol pesticide to be detected respectively. The result showed that the influence of interfering errors and pesticides in MP detection was negligible. Therefore, the prepared sensor has strong anti-interference for MP detection. Thank you.
Okay, thank you. And last questions. In chapter 6, why add zirconium dioxide to detect material paraffins? And what is the effect of composite materials on the sensor? Please.
Okay. Vacuum hydrous has strong absorption capacity for phosphorate groups, which makes the electrochemical sensor constructed based on vacuum structure have good molecular recognition and absorption performance for method policy. In particular, nanostructure zero cumulative endured materials has a large specific surface area, which is conducive to further improve the absorption performance of the materials, which enhance the accumulation ability of method policy. Thank you. That's all.
Okay. No more questions.
Thank you.
Friends, let me acquaint those present with the conclusion about the scientific novelty, theoretical and practical significance of the results of the thesis. Актуальність теми дисертації. Використання пестицидів є одним із заходів контролю шкідливих організмів в агробіоценозах. Однак, на жаль, залишки пестицидів забруднюють навколишнє середовище та рослинну продукцію. Для розробки науково обґрунтованих регламентів застосування пестицидів важливе значення має вивчення залишків пестицидів в рослинницькій продукції. Класично для цього використовують метод хроматографії газової або рідини. Цей метод є найбільш точним, але має ряд недоліків. Досить тривалий процес підготовки зразків для проведення аналізу, дороге обладнання, спеціальні умови та інші. Актуальним є проблема швидкого, простого та недорогого визначення залишків пестицидів. Одним із шляхів вирішення цієї проблеми є використання технології електрохімічного зондування. Зв'язок роботи з науковою тематикою полягає в наступному. Науково-дослідна робота проводилась відповідно до затвердженої теми дисертаційної роботи вченою радою Сумського національного аграрного університету та Хмельницького науково-технічного інституту в рамках наукової тематики. Національна ключова науково-технічна програма Китаю, є номер теж реєстрації, проєкт ключової дисципліни захисту рослин в провінції Хенань та програма «Тисячі талантів» Чунчжуань провінції Хенань. Наукова новизна і теоретична значення дисертації полягає в наступному. Встановлено особливості накопичення та деградації залишків пестицидів різними частинами рослин на різних овочевих культурах. Для визначення карбендазиму було застосовано датчик відповідний, який підвищив значення визначення залишків карбендазиму в овочах. Для підвищення здатності визначення залишків імідаклоприду використано датчик SPDS-GGS. Для ефективного визначення метилпаратінолу застосовували інший датчик SCB. Практичне значення результатів дисертації. Досліджено особливості поглинання, переміщення, розподілу та накопичення залишків пестицидів у гідропонних листових овочах. Це забезпечило наукову основу для управління раціональним та безпечним застосуванням пестицидів. На основі характеристик молекулярної структури пестицидів і функціональних наноматеріалів, технології електрохімічного зондування композитивного зв'язку було створено та протестовано нові електрохімічні датчики для швидкого, чутливого та точного виявлення залишків пестицидів, включаючи 3 види діючих речових пестицидів: карбендазим, імідаклоприд і метилпаратіон. Це дало гарантію безпеки рослинної продукції. Головні результати отримані особливо автором наступні. За результатами проведених досліджень встановлено особливості різних почвових культур поглинати, переміщати, розподіляти та накопичувати в різних органах залишки пестицидів. Внаслідок створення та тестування нових електрохімічних датчиків підвищено точність визначення залишків пестицидів за допомогою електрохімічного зондування композитивного зв'язку. Все це дає основу для розроблення безпечного використання пестицидів на сільськогосподарських культурах. Був проведений аналіз звіту перевірки на плагіат на наявність текстових запозичень програмою UNICHECK. Рецензенти дійшли висновку, що дисертаційна робота автора на тему порівняльна оцінка різних методів визначення залишків пестицидів у рослинницькій продукції є результатом самостійних досліджень здобувача і не містить елементів плагіату та запозичень. Використані ідеї і результати текстів інших авторів мають посилання на відповідні джерела. Кількість наукових публікацій автора є наступною. За результатом досліджень було опубліковано 15 публікацій в наукових виданнях, 5 наукових статей у виданнях журналів проіндексованих в базі Web of Science, 4 наукові статті, опублікованих в українському науковому фаховому журналі категорії Б, з них одна одноосібна. А решта 6 публікацій були доповідями на міжнародних конференціях. Так, зауваження і побажання по змісту відсутні. Відповідність дисертації, спеціальності та профілю ради. Дисертаційна робота Лі Фанг, порівняльна оцінка різних методів визначення залишків пестицидів у рослинній продукції, яка подана до захисту по спеціалізовану вчену раду на здобуття ступеня доктора філософії з галузі знань 20 аграрні науки та продовольства, за спеціальністю 202 захист і карантин рослин, за своїми актуальністю, науково-теоретичним рівнем, основними результатами фахових видань, основними результатами обґрунтованості, основними положеннями і результатами, опублікованими у фахових виданнях, новизною постановки та практичним значенням відповідають вимогам наказу МОН України номер 40 від 12 січня 2017 року про затвердження вимог до оформлення дисертації та постанови Кабміну України від 12 січня 2022 року за номером 44 про затвердження порядку присудження ступеня доктора філософії та скасування рішення разової спеціалізованої вченої ради закладу вищої освіти наукової установи про присвоєння ступеня доктора філософії зі змінами, внесеними з постановою Кабміна від номера 341 від 21.03.2022 року. Зміст дисертації відповідає паспорту спеціальності. Так, далі наступне. We begin the discussion of the dissertation work by Лі Фанг. Перед цим, шановні рецензенти і опоненти, я просив вас зупинитися, зокрема, на основних частинах, на які ви хочете виділити зауваження, які ви знайшли в роботі. В зв'язку з тим, що у нас ймовірність досить велика на переривання зв'язку через теперішню ситуацію в Україні. Так що, будь ласка, коротенько, бажано зачитувати лише зауваження. Так, будь ласка, Владислав Коваленко, вам слово.
Thank you. Let me start the discussion. Due to various influences, chemical pesticides are still widely applied in agriculture production. Chemical pesticides are continuously transmitted and accumulated in organic environment and live organisms through the food chain, which seriously endangers human health and ecological stability. Therefore, reducing pesticide residues and accelerating the degradation of pesticides have become the primary task in agricultural development. In the future, research of these substances that can decompose, volatilize, and transfer pesticides in leafy vegetable plants can be deeply studied. And the improvement of the pesticide residue detection technology can guarantee the safety supervision of agricultural products. What about general conclusion? Lí Fang's dissertation on the topic comparative evaluation of different methods of determining pesticide use in plant products, which is presented for obtaining for a doctor of philosophy, is the independent study containing scientifically based results in the field of 202 plant protection quarantine. In terms of content and formal features, the dissertation meets the requirements for the design of dissertations and the procedure for awarding the degree of Doctor of Philosophy approved by the resolution of the Cabinet of Ministers of Ukraine dated 20 of January 2022, number 44, which cancels the previous orders of the Ministry of Education and Culture of Ukraine dated January 20, 2017, number 40, and Ministry of Education and Culture of Ukraine dated May 31, 2019, number 659, with changes and additions. Thank you for attention.
You are given the opportunity to respond to comments of what have been posted in the review. Please, Lí Fang, your answer.
Okay, thank you for your suggestions. I will review them one by one. Okay, that's all.
Okay.
Yes.
You.
Discussion clauses, comments, and regarding the contents. The use of chemical pesticide has a positive effect of protection of crop disease and insect pests and improving the output of agricultural products. Therefore, chemical pesticides are still widely used in agricultural production. Chemical pesticides spread and accumulate in inorganic, environmental, and organism through food chain, which seriously harm human health and ecological stability. Therefore, reduced pesticides residue and acceleration pesticide degradation have become the primary task of agricultural development. In the future research, the substrate what can decompose vosylated and transfer pesticide in leaf plants can be deeply studied and improved. General conclusion. Lí Fang's dissertation on the topic comparative evolution of different methods of determining pesticide residues in plant products, which is presented for obtaining a Doctor of Philosophy, is an independent study containing specifically basis result in the field of 202 plant protection and quarantine in terms of content and formal future. The dissertation meets the requirements for the design of dissertations and the procedure for awarding the degree of Doctor of Philosophy, approved by the resolution of the Cabinet of Ministers of Ukraine date 12/1/2022, number 44, which cancels the previous order of the Ministry of Education and Culture of Ukraine dated January 12, 2017, number 40, and Ministry of Education and Culture of Ukraine dated May 31, 2019, number 759, which changes and additions. Andrei Butenko, PhD in Agriculture, Associate Professor of the Department of Agricultural Technology and Soil Science, Human Nature, Ukraine University.
Okay, Лі Фанг, your answer, please.
Okay, thank you very much for your valuable suggestions. The suggestion you mentioned are very useful, so I will make it better in the future. Thank you. That's all.
Okay. I invite a professional opponent to speak. Сергій Станкевич, будь ласка.
Thank
No.
you. Discussion clause comments and wish regarding the content. There are a few points towards discussion regarding the content of the dissertation. 1. Figure 1.2. The electrochemical sensing analysis method is one kind of novel analysis technologies. It is suggested towards the schematic diagram of electrochemical workstation and computer monitor in this figure to argue the better understanding of this sensing analysis method. 2. Figure 2.1. Electrochemical analysis system may be changed into electrochemical system analysis setting analysis system. The determination of pesticide may be changed into 3 electrode system. The figure caption 3 electrode system may be changed into electrochemical sensing analysis system for pesticide detection. 3. Clauses 3.2.1. The IMI concentration 0.1, 0.2, 0.5, 1, 5, 10, 20, and 30 micrometer for standard curve should be added in the figure caption of figure 3.2. Clause 4.1.1. The characteristic CV curve of important for the analysis of pesticide type by the of the electrochemical reaction peaks of pesticide. It is suggested towards the CV curve of CBZ determination in chain 4.1. Clause 4.2.2. According to the research about the influence of scan rate, the scan rate has a certain impact on the peak response of CV curve. Please add the scan rate in the figure caption of CV curve in figure 4.6. Please add the scan rate in the figure caption of CV curve of 15 micrometer CBZ at the bar GCE and MWC COOH GCE sensor in figure 4.3. Clause 5.2.6. Please revise the format of table 5.2 according to the format standard of dissertation. The format of the other tables need checked and revised in necessary. 8. The analysis of limits of detection is important for electrochemical sensing detection of pesticide. It is suggested to check and show the calculation formal limit of detection for the related section in this research work. General conclusion. Dissertation work of Lí Fang on the topic comparative evaluation of different methods of determining pesticide residues in plant products, which was submitted for defense to the Specialized Academic Council for obtaining the degree of Doctor of Philosophy in the field of knowledge 20 Agriculture, Sciences and Food. This is specialty 202 Plant Protection and Quarantine of Agricultural Production according to its relevant scientific and theoretical level, main result of validity, main provision, and the result publishing and professional publishing. The novelty of the formulation in the practical significance meets the requirements of the order of the Ministry of Education and Culture of Ukraine, number 13 of January 12, 2017, on approval of requirements of the preparation of a dissertation and resolution of Cabinet of Ministry of Ukraine of January 12, 2022, number 44, on approval on the procedure of awarding a degree Doctor of Philosophy and cancellation of the decision of the one-time specialized academic council of the institution of higher education scientific institution on awarding the degree of Doctor of Philosophy, which change introduced in accordance with resolution of Cabinet Ministry number 341 dated 21st March 2022. Thank you, attention.
Lee Fang, you're on draft, please.
Okay, thank you for your comments. After many reservations, my dissertation still have some progress, and I will do better in the future work. That's all. Thank you.
Okay. Сергій Володимирович, are you satisfied with the answer? Ви задоволені?
Yes, yes.
Okay. Давайте. Людмила Вікторівна, please, your report.
Thank you. There are a few points worth discussing regarding the content of the dissertation. One, class 1.3.3, the full name of all abbreviation should be and supplement in this path. The authors should check abbreviation on other sections. 2. Peak 3.2, please check the axis onions and stand-up cube equation of y equal 60 to 65 for x place 123.6. Clause 4.2.2 how to obtain the limit of detection. Successor should expression this point. 4. Table 4.3. Please reveals the analysis days to attribution the unification of significant digits as a table need careful check and revise if necessary. 5. Clause 5.1.2 severe nerve of detection is necessary for shame and the picture of vegetables used in this section should be checked. 6. The author should check all figure captions and revise some complements in necessary. 7. Some language errors and formatting errors need to be pointed. 8. Complement with traditional pesticides analysis method SER and HPLC. The electrochemical sensing, the electrochemical analysis method is a simple and novel detection method with low cost, high analysis efficiency, and high sensitivity. This research work is very important for the development of advanced pesticides analysis technology. The author should check and present the electrochemical detection mechanism of pesticides in each section. General conclusion. Dissertation work of Lí Fang on the topic comparing evolution of different methods of determining pesticide residue on plant products. Weak work supplement for defense to the specialist academic council for obtaining the degree of Doctor of Philosophy in the field of knowledge, 20 agricultural sciences and food with a specialist 202 plant protection and quarantine of agriculture production according to its rivals, scientific and theoretical level, main results of valued main provisions and the results published in professional publication on a novel of the formulation and the practical certification needs the requirements of the order of the Minister of Education and Culture of Ukraine number 40 of January 2027 on approval a recommendation of the preparation of a dissertation and resumption of the Cabinet of Ministers Ukraine of January 2022 number 44 on approval of the procedure for awarding a degree Doctor of Philosophy and consolation of the duties of the one-time Specialist Academic Council of the Institution of Higher Education, Scientific Institution of awarding the degree of Doctor of Philosophy with change introduction with revolution on the Cabinet of Ministers number 341 dated 03.21.2022. Thank you.
Okay, thank you, Victorina. Лі Фанг, please, your answer.
Okay, thank you. In the first comment, it is true that my dissertation is not clear. I will supplement it completely. And the following question do exist. And thank you for your comment. You are really careful, and this problem do exist after my previous revision. I will continue to revise these problems in my dissertation. Thank you for raising them. That's all.
Okay,
Yes.
Are you satisfied with the answer? Ви задоволені відповіддю?
Yes.
Okay, then later. According to the realize of work of the Specialist Academic Council, we processed to the discussion of the thesis of Lі Фанг. I emphasize what all present members of the Academic Council have the right to take part in the discussion. Please, Владислав Миколаївич.
Thank you. I must say that pesticides play a crucial role in boosting agriculture productivity and contribution significantly to social economic gains. However, research surveys indicate a growing concern over the escalation of pesticide residues in soil and water over the past decade. Crops, irrespective of the jurisdiction's use of the pesticides, are absorbing and transporting these chemicals, posing a latent threat of surprising safety standards for pesticide residues. This not only endangers crop quality, but also poses serious risk to both ecological systems and human health. Second, while staple crops like rice and wheat face such challenges, leafy vegetables characterized by distinct seasonality, economic importance, and shorter growth cycles have their unique set harvests. The stringent requirements of external environmental conditions, coupled with the prevalence of numerous pests and disease, result in widespread pesticide application in leafy vegetable production. This, unfortunately, has led to frequent instances of ecological pollution, prompting heightened societal awareness regarding the safe cultivation of leafy vegetables. Understanding the indications and patterns of pesticide absorption and transportation in leafy vegetables becomes imperative for effective pesticide pollution control. Next, conventional methods for detection pesticide residues, such as high-performance liquid chromatography and gas chromatography, through effective are encumbered by expensive requirement, prolonged analysis periods, high technical complexity, and specific detection conditions. In response to this limitation, the development of an analytical method for the swift detection and of pesticide residues gains paramount importance. Electrochemical sensor technology emerges as a key player in the realm, offering a rapid, efficient, and sensitive approach. Leveraging the advancements and nanotechnology, researchers are directing their efforts toward constructing electrochemical sensors tailored for pesticide residue detection. These sensors, based on nanomaterial characteristics, aim to provide a solution that is not only effective but also addresses the limitation associated with traditional detection methods. The pursuit of such innovative approaches holds great significance in ensuring the safety and sustainability of agriculture practice in the face of pesticide-related challenges. And the last, the dissertation aimed to investigate variations in pesticides absorption and transfer among different leafy vegetables and to explore the dynamic absorption and accumulation patterns in hydroponic later. Furthermore, the study involved the development of 4 electrochemical sensors utilizing carbon-based nanomaterial composites for the detection of 3 pesticides, carbendazim, imidacloprid, and methylparathione. The outcomes of the research indicated that electrochemical sensitive technology yielded satisfactory results when applied to pulverized vegetables. Additionally, high-performance liquid chromatography was employed to verify the precision of pesticide residue detection through electrochemical methods, confirming that electrochemical sensors can meet the requirement for detection pesticide residues in real vegetable samples. Moreover, the simplicity of operation, the rapid response of the electrochemical sensors opens up possibilities for on-site pesticide residue detection in agricultural products. And generally, I must say that Lí Fang's dissertation on the topic, comparative evaluation of different methods of determining pesticide residues in plant products, which is presented for obtaining a Doctor of Philosophy, is an independent study containing scientifically based results in the field of 202 plant protection and quarantine. In terms of content and formal features, the dissertation meets the requirements for the theme of dissertation. Thank you for attention.
Okay, thank you. Lí Fang, please, Andrei.
Pesticides serve as a vital tool in enhancing agricultural productivity and contributing significantly to economic trends in society. However, recent surveys highlight growing concern regarding the increasing levels of pesticide residue found over the past decade. Even when pesticides are used judiciously, crops are absorbing and transporting these chemicals, so every presenting a latent threat of exiting safety standards for pesticide residues. This not only jeopardizes the quality of crop, but also poses serious risk to ecological systems and human health. Leaf vegetables distributed by their decent certainly economic significance and certain growth cycle face a unique set of obstacles. The demanding environmental concern in this crop require calculate which the prevalence of various pests and diseases have led to expensive pesticide use the leaf vegetable cultivation. Unfortunately, this has result in frenzied instance of ecological pollution, promoting and heightened social awareness of the importance of vegetable production. It's vital for effective control of pesticide pollution to research in the interactive processes of pesticide absorption and transportation in vegetables. Conventional methods for detecting pesticide residues, such as high-performance liquid chromatography and gas chromatography, while effective, are hindered by the need for expensive equipment. Later analyzed period high technical complexity and specific detection conditions gives this limitation the development of an analytical method for the rapid detection of pesticide reduces becomes of paramount importance. Electrochemical sensor technology emerged as a key player in this field, offers a swift, efficient, and highly sensitive approach to address this challenge. Using the advances in nanotechnology, researchers are actively focusing the efforts of the development of specialized electrochemical sensors designed for the precise detection of pesticide residues. This cutting-edge sensor, which leverage the unique properties of nanomaterials, are intended to not only enhance detection effective, but also overcome the limitation associated with these conventional detection techniques. The pursuit of such innovative approaches is of paramount importance in ensuring this safety and sustainability of agricultural practice, especially in light of the challenge posed by pesticide use. The primary objective of the dissertation was to investigate the variance in pesticides absorption and transfers among different types of leaf vegetables. A detailed study aimed to explore the dynamic patterns of pesticide absorption and accumulated in hydroponic growth latitudes. Furthermore, this research project encompassed the development and evolution of 4 distinct electrochemical sensors that make use of carbon-based nanomaterials and composites. These sensors were specifically designed for the detection of these pesticides, carbendazole, imidacloprid, and methyl paraffin. The research findings from this study demonstrated that electrochemical sensors technology yielded satisfactory results when applied to a wide range of vegetable samples. To validate the accuracy of pesticide reduce detection through electrochemical methods, high-performance liquid chromatography was employed. The result of analysis confirmed what electrochemical sensors meet the precise requirements for detecting pesticide residues in real vegetable samples. Editing shows the years of operation and rapid response times associated with electrochemical sensor of open up new possible for on-site pesticides residue detection in agricultural products. Lí Fang's dissertation of the topical of the topic, comparative evolution of different methods of determining pesticide residue in plant products, which is presented for obtaining a Doctor of Philosophy, is the independent study contained scientifically based results in the field of 202 plant protection and quarantine in the term of content and form futures. The dissertation meets the requirements for the design of dissertations. Thank you.
Okay, thank you, Андрій Олександрович. Please, Сергій Володимирович.
Так, будь ласка. The pesticides are widely used in agricultural production and bring huge economic benefits to society. According to the existing survey in recent 10 years, the problem of pesticide residues is more serious, and crops can absorb and transport pesticide in soil and water, which leads to the heightened danger of pesticide residues exceeding the standard in crops with or without reasonable application of pesticides, and cause great harm to the ecological, environmental, and human health. Therefore, study accurate, rapid, and convenient pesticide detection and analysis methods in agricultural products are very important to protect human health and environmental safety. In this dissertation, the difference of pesticide absorption and transfer in different leaf vegetables were studied, and the dynamic absorption and accumulation rules were explored in hydroponic cultures. In addition, 4 kinds of electrochemical sensors were prepared based on carbon-based nanomaterial composites for the detection of carbendazim, imidacloprid, and methylparathione, respectively, and satisfactory results were obtained in vegetable samples. HPLC method was conducted to confirm the accuracy of pesticide residues by electrochemical detection, and so experimental results showed that electrochemical sensing technology can meet the requirements of pesticide residues detection in actual vegetable samples. Moreover, shows advantages of simple operation and fast response in electrochemical sensor provide the possibility for one-side detection of pesticide residues in agricultural products. Therefore, the research direction of Dr. Lí Fang is to detect pesticide residues in crop by electrochemical sensor methods, so as to provide warranty for the consumption of crops. Dissertation work of Lí Fang on the topic comparative evaluation of different methods of determining pesticide residues in plant products, which was submitted for defense to the Specialized Academic Council for obtaining the degree of Doctor of Philosophy in the field of knowledge 20 Agricultural Sciences and Food with a specialty 202 Plant Protection and Quarantine of Agricultural Production according to its relevance, scientific and theoretical level, my results of validity, my provision, and the results published in professional publications, the novelty of the formulation and the practical signification meets the requirements. Thank you for attention.
Thank you. Please, Людмила Вікторівна Немарицька.
Thank you. The pesticides and whether they may used in agriculture production and bring huge economic benefits to society, economic to the existing survey in recent 10 years. The problem of pesticides residue in more serious, and crops can absorb and transport pesticides in soil and water, which leads to the hidden danger of pesticide residues exceeding the standard in crops with or without reckless application of pesticides and causes great harm to the ecology, environment, and human health. Therefore, steady, equipment, rapid, and convenient pesticides detection and analysis methods in agriculture production are very important to protection human health and environmental safety. In this dissertation, of pesticide and absorbent and trends on different leaf vegetable were studied and the dynamic evolution and accusation rules were explosion and hydroponic ledges. In addition, 4 kinds electrochemical sensors were prepared based on carbon-based nanomaterial on composites for the detection of carbondazine, imidacloprid, and material pyrazine respectively, and satisfactory results were pesticide residue by electrochemical detection, and those experimental results showed that electrochemical sensing technology can meet the requirements of pesticide residue detection in actual vegetable sampling. Moreover, those advantages of simple operation and fast reactance as electrochemical sensor provide the possibility for on-site detection of pesticide residue in agriculture product. Therefore, the research direction on Dr. Lí Fang's thesis in to detect pesticide residue in crops by electrochemical sensor method so as to provide guarantee for the controlling of crops. Dissertation work of Lí Fang on the topic evaluation of different methods of deterring pesticides residue in plant production when been sibling for different to the specialist academic council for obsession the degree of doctor of philosophy in the field of knowledge 20 agriculture science and food with a specialist 200 to plant protection and quarantine of agriculture production ecology to its relevance scientific and theoretical level main results of validity main proficiency and the results published on professional publication in the novelty of the formulation and the practical confidence meet the occupants. Thank you.
Thank you, Lyudmila Viktorovna. Okay, Lí Fang, please, your advert. Oh, no, bitte. Please. I have 2 words I'll speak. The use of pesticides is one of the measures to control pests in agrobusiness. Unfortunately, pesticides residues contaminate the environment and plant production. In order to develop scientifically sound regulation for pesticides use, it is important to determine pesticides residues in plant products. Classically, this is done using gas or liquid chromatography. This method is the most accurate, but has a number of drawbacks, rather lengthy process of sample preparation and analysis, expensive equipment, special condition. The problem of quick, simple, and inexpensive determination of pesticides residues is still relevant. One way to solve this problem is to use the electrochemical sensing technology. The peculiarities of the absorption, movement, distribution, and accumulation accumulation of pesticide residues in hydroponic leafy vegetables were investigated. This provides a scientific basis for managing the rational and safe use of pesticides, based on the characteristics of the molecular structure of pesticides and functional nanomaterials and the technology of electrochemical sensing of composite bonds. New electrochemical sensors were developed and tested for their pitch sensitive and accurate detection of pesticides residues, including 3 types of pesticides active ingredients: carbendazim, imidacloprid, and methyl paraffinose. This ensures the safety of plant products. Lī Fang dissertation, comparative elements of different methods of determining pesticide residues in plant production, submitted for defenders of the Specialist Academic Council for the degree of Doctor of Philosophy in the field of knowledge 20, agricultural science and food, specialty 202, plant protection and quarantines, meets the requirement to relevance scientific internal level. My results of validity, my provisions and results published in professional journals. Novelty of the statement and practical significance. Does anyone else want to speak? Чи бажає хтось ще щось виступити, сказати? If there are no objections, I suggest ending the discussion. Нема заперечень, тому я припиняю нашу дискусію. Нами попередньо був розроблений проект рішення спеціалізованої вченої ради. Дозвольте його зачитати. Спеціалізована вчена рада Сумського національного аграрного університету, Міністерства освіти і науки України місто Суми прийняла рішення про присудження ступеня доктора філософії в галузі знань 20, аграрної науки та продовольства на підставі прилюдного захисту дисертації, порівняльна оцінка різних методів визначення залишків пестицидів у рослинній продукції. За спеціальністю 202 захист та карантин рослин. Лі Фанг 1989 року народження, громадянка Китайської Народної Республіки, вища освіта має, закінчила в 2015 році Сікуанський університет Китайської Народної Республіки за спеціальністю комп'ютерна архітектура. Аспірантуру вона закінчила у 2023 році у Сумському національному аграрному університеті Міністерства освіти і науки України місто Сума. Дисертація була виконана в Сумському національному аграрному університеті Міністерства освіти і науки місто Сума. Науковий керівник Дубовик Володимир Іванович, кандидат сільськогосподарських наук, доцент кафедри біотехнології та хімії Сумського національного аграрного університету. Здобувачка має 15 наукових публікацій за темою дисертації, з них 4 статті у наукових фахових виданнях України, 5 статей у виданнях, які включені до міжнародних наукометричних баз Scopus та Web of Science, 6 інших публікацій. Тому переходимо до відкритого голосування. Так, прошу членів спеціалізованої вченої ради проголосувати і озвучити рішення щодо присудження Лі Фанг ступеня доктора філософії за спеціальністю 202 захист та карантин рослин. Оленко Владислав Миколаївич, ви за, проти?
За.
Утенко Андрій Олександрович, за, проти?
За присудження.
Станкевич Сергій Володимирович, за чи проти?
За присудження.
Немирицька Людмила Вікторовна, за чи проти?
За присудження.
Ну і я, Юрій Міщенко, за. Таким чином, за присудження Лі Фанг ступеня доктора філософії за спеціальністю 202 захист і карантин рослин є 5 голосів за, проти голосів немає. На підставі результатів відкритого голосування спеціалізована вчена рада присуджує Лі Фанг ступінь доктора філософії у галузі 20 аграрної науки та продовольства за спеціальністю 202 захист та карантин рослин. Чи є зауваження щодо рішення спеціалізованої вченої ради, шановні присутні?
Немає.
Немає. Так, отже, дозвольте привітати Лі Фанг з успішним захистом дисертації. Лі Фанг, we congratulate you. Okay.
Thank you.
Надається аспіранці Лі Фанг. Лі Фанг, please.
Okay. My study at Sumy National Agricultural University will soon come to the end, and the defense of my graduation dissertation I wish to express my sincere appreciation to all those who have offered me invaluable help during the over 4 years of my study. Firstly, I would like to express my hearty guidance to my tutor, Professor Dobrica Vladimir, for his constant inspirations and guidance. He has walked me through all the stages of my dissertation. Without his consistent and illuminating instruction, this dissertation couldn't have reached this present form. Secondly, I should give my hearty thanks to all the other faculty members of the Sumy National Agricultural University for their patient instructions and their precious suggestions for my studies. Lastly, my thanks would go to my beloved family for their loving considerations and great confidence in me all through these years. I also owe my sincere gratitude to my friends and my fellow classmates who gave me their help and time in listening to me and helping me work out my problems during the difficult course of the dissertation. Thank you all of you. That's all.
Okay, Лі Фанг, all the best for you. Так,
Thank you.
так. Дякую всім присутнім. На цьому засідання спеціалізованої ради вважається закритим.